Hello, everyone, and welcome to episode 4 of the Wow Such Games Devlog series. If you don't know me, or if this is your first time joining us, my name is Josh, and I am the owner-operator of Wow Such Games. Today, I'm going to be showing you a visual scripting tool that we've developed and that we're planning on using for Project Icarus. So let's skip the small talk, and we'll dive right in. So the visual scripting system starts with something called a graph. So we'll create one of those the normal way that you do in Unity by going to the Create menu. We'll go up to Wow Such Games, Visual Scripting, and we'll create a graph. And we will call this our example graph. When I click on this graph and go to an inspector window, you can see that I get a couple options here. I have a button to open the graph and then a place to enter a test process. So I'm just going to do a bit of work ahead here and enter an example process name, and we'll click the open button and we'll get our graph editor here. So as you can see, this graph editor canvas is completely empty. I can add content to a graph by right-clicking and selecting the node that I want to create. So the first thing that we'll create is called a process entry node. So this is the entry for any type of process or logic that you would like to create in the visual scripting system. Of course, a process entry indicates that we also need a process exit. And here we have the most basic process, which does nothing. It just enters and exits. Of course, that's not very fun, so we'll break that connection and we'll create ourselves a log node. So what this node is going to do is it's going to log the value that we pass into the value argument here into our console. If we click on the log node, we can see in our inspector that it has a graph, which points to our example graph. So that's the parent graph, and a priority. We'll come back to the priority later. And if we take a closer look at the log node itself, we can see that it requires a couple arguments. The first argument that it requires is called value. So we'll create a value, and it will be a string. And our string is, this is a log message. And we can point our string to that value. It also has a format. We won't be discussing that quite yet. Now, we've almost got our very first graph and process built. We're just missing one other thing. When we want to run a process on our graph, we need a process ID. We've already typed in a process ID here. So now we need to tell it to use that same ID in our process entry. So the way we do that is by creating another string and hooking it up, and then clicking on that string and copying the same process ID into there. So now we have a graph and we have a process. Our process is very simple. It just logs a value to the debug console. Now I can run the test process called example process, and we can see that it outputs my message. This is a log message into our debug console. And so that's probably the most basic example that you could create of a visual scripting graph. Now, before we go on, I'd like to stop for a second and explain a little bit about the graph. A graph, as you can see, is made up of nodes and then connections or edges. So when you drag something like this, you're creating a connection between two nodes. Everything flows from left to right. So for our very simple process, the process enters here by its associated ID. The next thing it moves into is this, which logs our message to the console. And finally, it exits. So we still have an argument here that we're not using called format. So for those of you familiar with Unity or C#, you know what a format string looks like. So I will create a new string value and hook it up. And in here, we'll give it the format. This is my format. And we will include all of the typos because we don't care about them. Now when I run this test process, I get a different message. I get this is my format, and then I get this is a log message. So what it does is it takes the value here and inserts it where it finds this bracket 0 bracket. So far, we've shown how to log a simple message to the console, but we want to do something a little bit more complex. So we're going to delete these two nodes. The first thing we'll do is create a node that can add two numbers together, and we'll insert that into our value. So I'm not sure if you noticed, but this value was able to take a string or a number. Just like Unity can log anything to the console, the visual scripting system can also log any value to the console. Now, in the number node, we can see that it has a left and a right value, and it will add those two values together and output it into its number output. So let's create one number, and we will set that value there, and we'll set the value here to 10. Rather than creating another static number, this time we'll create a random number, and we'll hook it up to the right value. Now, this one has a few more options. We have a min value, a max value, and a useInts value. So we'll set our minimum, and we'll create another one for maximum. Grab both of those and drag them in. And we'll set our minimum to 10 and our maximum to 20. So now our output will be the result of this addition, which will add 10 and a random number between 10 and 20. And the last thing we have to do is hook up this useInts. Now that expects a Boolean, and a Boolean is just a true or false value. So we'll take this one in here and hook it up, and we'll set it to true. So an int is a number which is a whole value, so 10 or 3 or 942, and that's different than a floating point number which has decimals in it, so 23.4 or 89.725, something like that. If we were to turn this value off, it would use numbers with decimal places. If we turn it on, it will only use whole numbers. So now, when we run this process, we get the number 21. If we run it again, oh, we got 21 again. Now we got 20, then we got 25, 29, 25, so it just keeps giving us random numbers. Now, if we wanted to log this number twice for some reason, we could do that. We could add another log, hook it into the flow, and then hook the value in, and we'll get two messages when we run this process. But they're not the same number. That's because every time we ask for a random number, it's giving us a different one. So the first time, it gave us 25. The second time we asked for a random number, it gave us 28. But that's not always very useful. Sometimes we want to cache those values, we want to save those values and use them later. In order to do that, I can create a setLocal node. Now what a setLocal node does is it creates a key value pair where the key is a string and the value is, well, any object. And it saves that value so that you can use it later on in your graph. So I will grab all of these, pull them over here, move my setLocal node up into here so that it happens first. And then we can do our two logs. But we don't want them to log the value anymore. We want them to log a getLocal value. So you can see we have a setLocal and a getLocal. So these are ways of setting and getting local variables. So I'll drag this over here and put it in our value. But we're still not quite done yet because we haven't told the local what we're saving or where we're saving it. Saying what we're saving is easy. We just drag it in there. Where we are saving it is another string. So we create one, we drag it in, and we give our local a name. I am going to call this random number. And same thing when we get a local, we need to know what key it is. So I can either create another string node and type in random number again, or I can just use the same one and drag it in here. So now if I run this process, I should get the same number twice. And there we go, 27 twice. We can also add a format string. And we can call that string your number and insert it there. And now when we run this process, we got your number 27. Run it again, your number 27. Sure likes 27, 24, 26, 29. Now, as you can see, because these graphs flow from left to right, we tend to start to run out of room. But what we can do is create a transport out node down here and create a transport in node up here. And we can transport the flow from here to here. And the way that it does this is with an ID. So that's another string. And we'll give this one a simple transport ID. And we can drag it in there. Oh, transport ID. And then we can do the same thing down here and hook up our flow here. Now this transport ID, I'm just calling it transport ID. It can be called anything. As long as the two values match up, it will find them and transport your flow from here all the way down to here. So this way we can kind of teleport our flow across the graph. If we didn't have this ability, we'd end up having edges strewn across our graph like this, and nobody wants to see that really. All right, the final thing we're going to look at today is how to add some simple logic into a graph. So I'm going to move this all the way out here. So the first thing I'm going to do is create a conditional flow node. So most flow nodes don't have any conditions. They are entered and exited without any sort of thought. A conditional flow node, however, has to have a condition true before it can be entered. And the condition that we need to check gets entered into the value. So rather than doing a simple true-false Boolean, we're going to do a coin flip, which gives us a random true-false every time we ask for one. So we'll move our flow from here and into here. The next thing we need to do is add some action that will happen if this is true. So we'll keep on with the log actions, and we'll move this one up here. And we'll delete that. And our value that we're going to log will be condition is true. So the flow will only enter this node if this coin flip returns true. If it doesn't, well, as of right now, nothing will happen. But we'll set up another type of node called a transfer flow node. And this is a type of node that doesn't really do anything except transfer the flow from one area to another. So now we have two choices of where to go out of this node. And since we hooked up a second one, you can see this one will get checked first, and this one will get checked second. We can change this by changing their priorities. Each flow node has a priority. We can adjust that. If I make this one lower, you'll see that the numbers flip around. If I move it back up, it'll become number 1 again. So when a flow exits a flow node, it checks all of its adjacent nodes and makes sure that it goes through them in order. The first node that it finds, which allows flow, then it enters that node. So if our coin flip evaluates to false, we'll come into here and we will do another log action. And we'll do another string. And we'll hook it in. And this string's value will be condition was not met. And we'll hook up our flow here. And the last thing we need to do is add another transfer node. I don't know if you noticed before, but I'm able to adjust the number of nodes that are able to flow into this one. In this case, we need 2. One here and one here. And finally, we hit our exit. So if we've done everything correctly, we should see one of two values for the end. Either condition is true or condition was not met. So let's execute this and see what happens. And there we go. We still get our number 24 twice. And then we get a message that says condition was not met. Let's run it again. Now we got 20s and condition is true. Let's run it one more final time. And we got 29s and condition was not met. So there you have it. We have a graph with logic, variables, randomness, and a few other cool things. And that's everything for today. I hope you enjoyed this little deep dive into some of the tech that's driving Project Icarus, and I hope it didn't get too nerdy for you. Our next devlog will be coming out July 3rd, and in it I will be exploring another core system used to build Project Icarus. This one's called the equation system. Thanks for joining us, and we'll see you next month.